Alright guys, so what we're looking at today is deductive reasoning. So we're starting deductive reasoning. We're not going to do everything today. We're going to do some of it. We're going to talk about the law of detachment and law of syllogism. Now the main thing with deductive reasoning is we use facts. Facts, definitions, accepted properties, and laws of logic to form a logical argument. This is different from inductive reasoning, which uses specific examples and patterns to form a conjecture. So inductive is pattern, something we can see and show, or kind of see an example, visually see the pattern, see what's going on. So deductive reasoning is using facts, definitions. Accepted properties, laws, these properties. It's not something that we can see, it's something we know, we can prove. We can prove that it's true. We're using facts, definitions, and accepted properties of laws of logic to form an argument. Now, there's two main arguments or main ways we can do it. And the first one's law of detachment. Now, the law of detachment pretty much says if the hypothesis of a conditional statement is true, then the conclusion is true. So if the hypothesis is true, the first part of the statement is true, then the conclusion is true. And that's it. Now, law of syllogism pretty much says if P, then Q. If Q, then R. Then we can say if P, then R, because the conclusion of one matches the hypothesis of the other. Since these match up, it means we can say that these two here are true as well. And that'll make more sense when we see it. Now, the first thing we're going to look at is law of detachment. Law of detachment is pretty much if the hypothesis is true, then the conclusion is also true. So our general statement, so I'll go on and highlight that. So our first main statement is this here. If two line segments have the same length, then they are congruent. So our statement again is if two line segments have the same length, then they are congruent. So if the hypothesis is true, then the conclusion must also be true. So our hypothesis is what? Two segments have the same length. Okay, so let's keep reading. You know that BC is equal to XY. So this here, again, when they don't have the line above it, we're not talking about the segments. We're talking about the lengths of the line. So we're saying that BC, line BC, is equal to the distance from X to Y. So the distance from B to C is equal to the distance from X to Y. The segments have the same length. Using the law of detachment, what statement can you make? Okay, so what was the hypothesis? The hypothesis for this here is if two segments have the same length, then they are congruent. Well, what did we just say here? We just said here, right here, that the two segments have the same length. So therefore, it means that the two lines have to be congruent. So we're saying that BC is congruent. Congruent to X, Y. And then again, when we do these here, we have to do the line above it because it's a segment. And that's it. Because of the fact that these two segments were the same, BC is equal to XY, the segments have the same length, it means that they're congruent. So we can say that BC is congruent to XY because our hypothesis was true, the hypothesis that the two lines have the same length. So let's look at another one. So let's look at this here. So if a figure is a square, then what? Then it is a rectangle. If a figure is a square, then it's a rectangle. So if we have a figure that is a square, it means it's a rectangle. That's just what this statement is saying. Okay, you know that a quadrilateral, ABCD, is a square. Using the law of detachment, what statement can you make? Well, again, is the hypothesis true? The hypothesis is what? A figure is a square. ABCD is a square. Then it is a rectangle. So is the hypothesis true? Yes, we said ABCD is a square. If a figure is a square, ABCD is a square. So ABCD is a rectangle. Because the hypothesis was true. It said that it was a square. It is. Because ABCD, it says right here, it is a square. So, because of our law of detachment, since the hypothesis is true, the conclusion must also be true. So ABCD is a rectangle, or ABCD is also a rectangle. And that's it. Because the hypothesis was true, the conclusion must be also. So let's do this one again. So we're going to do one more of these here at least. I think we have one more. If 90 degrees is less than the measure of angle R is less than 180, then R is obtuse. So our hypothesis is this right here. This right here. 90 is less than the measure of R is less than 180. If this is true, then R is obtuse. The measure of angle R is 155. Using the law of detachment, what can we say? So, get my special characters out. See if it has it. Doesn't look like it. None. I'll just make one. So what we're going to say, angle R. So the measure of angle R is 155. Is 155 between 90 and 180? Well, yes. And since it is true, since this part of the statement is true, it means the conclusion is also true. So R is obtuse. Angle R is obtuse. Angle R is obtuse. Because of the law of detachment, since the hypothesis was true, the conclusion must be true also. Now, if the hypothesis is false, if something talks about here it's false, then we can't say anything. Then it's just not possible. Because if it had said, let's see here, let's figure all this out. So, white. There we go. So let's say it told us this here. Same problem, except R is 55 degrees. Well, is 55 degrees between 90 and 180? Because now we changed it, because it is 55, not 90. Well, no. The hypothesis, this right here, the hypothesis, R is not between 90 and 180. So this here has become not possible. We can't say anything. It's just not possible. We can't say anything about the angle because it does not make the hypothesis true. Because 55 degrees isn't between 90 and 180, so the hypothesis isn't true, so we can't say anything. It's just not possible. Not possible to do anything. So this right here is the last thing we're going to look at. We'll look at it again tomorrow. But law of syllogism, if possible, use the law of syllogism to write a new conditional statement that follows the pair of true statements. So when we look at these two statements here, if x squared is greater than 25, then x squared is greater than 20. That's one statement. If x is greater than 5, then x squared is greater than 25. Okay. Now, one of the things we look at with law of syllogism is two statements that match. So if I look at this here, x squared is greater than 25, shows up here and here. And for this to work, for us to be able to use law of syllogism, we need an if of one statement. So here, x squared greater than 25. This right here, we need an if and a then to match. And we have that. X squared is greater than 25. X squared is greater than 25. So we have those two statements. Now what we do next is we can use the law of syllogism. That tells me we can use it because if the if of one and the then of the other match, they are the same statement, we can use this law of syllogism to make a new statement. And what we do is we take the if of one, the one that isn't matching. So here x is greater than 5. Because that's the one we didn't use. That's the one that didn't match up. this down here. We take the if of this one and attach it to the then of this one. So then we would say then x squared is greater than 20. And that's it. That's all we have to do. If the if and then match up, then we match the other two up as our new statement. So let's look at this one here. If a polygon is regular, then all angles in the interior of the polygon are congruent. If a polygon is regular, then all its sides are congruent. So let's see what matches up. So if we notice this here, a polygon is regular. So we have one statement, a polygon is regular. Now hold up. Now this might be a little bit different, and it is, because if we notice something specific, there's one thing that's very specific about this example here, and that's the two statements that match up are both in the if part of the statement. It's if a polygon is regular, if a polygon is regular. Because what we need is for it to be an if and then. So this here is actually not possible. This one here is not possible. So let's look back to the one that was. Well, the one that did work, the if and then, it had an if of one match the then of the other. They weren't on the same one, like this one here, because it's both of the if statements match up. We need an if in one statement matching up to the then in the other. Because if we have two of the if statements matching up, or say if it was two of the then statements matching up, the conclusions, then it wouldn't work. We need one statement with if matching with the other statements then. So let's look at this one here. So let's see what matches. If you get an A on your math test, then you can go to the movies. If you can go to the movies, then you can watch your favorite actor. You can go to the movies. You can go to the movies. So this matches up. So we have an if of one and then of the other. So that means this does work, and we would combine the other two. So our new statement would be if you get an A on your math test, then you can watch your favorite actor. And that's it. That's all we have to do for this here. So we have two more left, and then we're going to be done for this here, and we'll pick this up tomorrow. So the first one out of the last two that we're going to do is, if possible, use the law of syllogism to write a new statement from the pair of statements. If soccer practice is canceled, then you can go to the mall after school. If it's raining today, then soccer practice is canceled. So we have soccer practice is canceled here, because I think I saw that. Yep, I saw it up here too. So soccer practice is canceled is the main statement. Now the big thing again, is it an if and a then matching up? If soccer practice is canceled, then okay, soccer practice is canceled. So we do have an if and then. So that means that the law of syllogism will work. Now this one here, again, when we plug these back in and we rewrite it, the one with if goes first. If it is raining today. If it is raining today. So that goes first. If always goes first in these statements. It is raining today. Then you can go to the mall after school. And that's all we have to do for this here, because we matched up those two statements. So if it's raining, then you can go to the mall after school. Now that brings us to the last one. This one here is the last one we're going to do. If a figure is a rectangle, then all interior angles are right angles. If a figure is a square, then all interior angles are right angles. So hey, I noticed that all angles are right angles. All interior angles are right angles. Because that was in one here, and it's in this one here. But if you notice something specific, it's both in the then. Then all interior angles are right angles. Then all interior angles are right angles. So since it's not an and if, one statement being if and the other then that's matching up, this right here is not possible. We're not going to be able to make a statement based off this here. We're not going to be able to make a statement based off this here. So we're going to finish this lesson tomorrow. It's a nice short one this time. And again, since it is a virtual day, you need to go and take your one question quiz. So go take the one question quiz and you will be done for today, and we will pick this up tomorrow.